So in this chapter, what we're going to do is learn more about chemical reactions and try to understand why reactions take place. And we're also going to learn how to write chemical reactions in a way that we can communicate it to other people. So we've discussed chemical reactions before, and there's 5 signs of a chemical reaction. There's color change, uh, when a solid forms from 2 homogeneous solutions or clear solutions, right? Gas formation, and remember we evidence that by seeing bubbles coming out of a solution. If you can remember back to experiment 1's videos, we can have light that's produced, like a glow stick, for example, is a chemical reaction. It's the kinds that you see on the 4th of July. And then you can also experience temperature change. That is, reactions can give off heat, and we describe those as being exothermic reactions, and they can also absorb heat, which we described as endothermic reactions. So I'm not going to say much more about the signs of chemical reactions. We've kind of looked at that in some detail. But I'll say that we'll look at several of these reactions and what it means when those reactions take place in terms of like chemical symbols and chemical equations. So when we write chemical equations, there are certain distinct parts, and you sort of need to know the names of the different parts sort of to communicate about this. And so we have the reactants. Now, the reactants are on the left side over here. And actually, I'll use a highlighter like this one. These are my reactants for A, right? And then my products will be here. Now we have a reaction arrow. So this is A, right? This is B. The reaction arrow C, and the reaction arrow C is kind of a place where we store a lot of information about the reaction. We often indicate like whether or not the reaction is being heated or whether or not it's at room temperature. So if it's being heated, the symbol, what we would say, is a delta. It's the uppercase Greek letter D. But if it's actually at room temperature, we might specify 25 degrees, and so you might see any one of those things on the reaction arrow depending on the conditions of the reaction. It could also be at higher pressure, so the reaction conditions, or it could be under acidic conditions or basic conditions. And those are all things that sort of get stored on the arrow, and it's kind of the place people look to sort of understand how a reaction was done. The last thing on the list is a catalyst. And a catalyst, if you've taken biology, you've heard of enzymes being the biological catalysts, but a catalyst just makes reactions faster. It doesn't belong in the reactants or the products, so oftentimes it's left on the reaction arrow, and that's sort of its home. So for example, platinum is a very common catalyst in chemistry, and they would write PT, the symbol for platinum, under the reaction arrow usually. Now, the other things that are on the chemical reactions, some of them you are familiar with, right? The chemical formulas are there, but we also have the states. Now, the states mirror the physical states of matter. So we have solids, liquids, and gases, but they also represent the solution state. So if you have a homogeneous solution, that is, you've taken something and you've dissolved it, for example, in this case, water, what we would say is that it's aqueous. So AQ stands for aqueous, and it specifically means a homogeneous solution in water. So the last thing on here you're perhaps not familiar with, but it's these numbers that are here. And these, just like in math, get termed coefficients, but in chemistry they have a special term related to it. It's called the stoichiometric coefficient. Oops, got an extra E in there. And forgot my T. There we go. So a stoichiometric coefficient has a special purpose. Its goal, okay, big picture goal, is to balance the mass on the left side of the reaction with the mass on the right side of the reaction. The way they do it, or the way they're supposed to do it, is by making sure the number of each type of atom that's on the left side shows up on the right side. So let's take a look at this reaction real quick. And I'll tell you, I put coefficients in here, but it turns out this reaction isn't balanced. And the reason I know that, the one thing that gives it away, is this hydrogen. There's 6 hydrogens in that compound. If this reaction was balanced, there would be 6 hydrogens on the right hand of the equation. Now you'll notice these coefficients, like this 3 represents the fact that there would be 3 oxygen molecules or 6 oxygen atoms. And then that's the same thing that this coefficient would mean. And there's 1 oxygen and 1 oxygen here. So at first glance, this reaction appears to be balanced. But like I said, the hydrogens are not balanced. And we'll balance this equation later because there's only 2 hydrogens on this side. So in the process of balancing this the first time, many years ago, I left that step out, but it's easy to recognize when it's not balanced, so I can come back and fix it, okay? So many years ago, I made that mistake, and as I was giving the lecture, I realized it's not balanced, and I thought it was a good teaching moment for the students that sometimes we make mistakes, but many of the mistakes we make in chemistry are easy to spot if you're careful and check your work. And so in this case, I didn't check my work before I wrote the notes, but it's a good opportunity to teach you how to balance equations. So let's look at some equations and practice balancing, and I'll give you some pointers on how to do it.